ostracod diversity, and they are especially difficult because there are so many fossils described. So we provide here the first key to representatives, to families with living representatives, which is very good. So this one, new interesting species, was very small, 0.5 millimeters. And going through literature, we have found that there is another one, another genus, which we put together in a new family, Caesaridae. And this new genus, another genus, was found 50 years ago, living commensally on one isopod, Linoria lignorum, so also on driftwood, but not in deep sea, but found offshore of Norway. And the new family is characterized with some interesting features, some very strong claws on the second antenna and on the mandibula, but we have found also that there are many convergent characters between these ostracods found living in the driftwood and interstitial ostracods, so those living between sand grains on the beaches. But when you imagine a driftwood with all these small holes, it's not really unlikely to have convergent characters between these animals living in these environments and the ones living in the interstitial waters. So here are some publications based on the living ostracods from deep sea. And bear in mind, this is not all, but it's most of it, so not much of it published so far. And now to go back to the recent deep sea ostracods, and again to point out, recent doesn't mean living, that doesn't mean that all of them are described based on soft and parts on their shell. And these data are from over 2,000 meters depth, and then there are 3,681 records coming from 700 stations around the world. And this is just almost no data from Clarion-Clipperton fracture zone. There is a strong geographical bias to where the samples come from. So you can see Atlantic Ocean, especially North Atlantic Ocean, is well covered, while some areas, huge areas of Pacific, are literally unknown. Also, there is a strong bathymetrical bias. Most of the data come from down to 3,500 meters, and higher depths have much less samples and therefore reveal much lower diversity. So, putting all together, we come to these numbers. So 37 families found in deep sea, about 200 genera, and about 500 species. When you consider the current diversity of recent ostracods, this is a little bit more than 5%, and this is very small. And also we have again to address problems. 40% of these 500 species were described in 19th century and the beginning of the 20th century. So the knowledge on taxonomy was very poor. Also, they were described based on shells only. And even those shells, 20% of them were smooth shells. So you lose even the information about their ornamentation. And they are all thought, many of them are thought to be cosmopolitan. And here we have to address these questions. This question is, does cosmopolitanism at species level exist in ostracods? And here I have chosen one example that was recently published by Grandau and Netsuhara, so in 2013, and it is based on one species, Henrichovella dasyderna, which was known from 200 to 5,100 meters, from Eocene to Recent. And I have chosen this example because this is based on shell only, but it is just to show you that even looking in shell is very often superficial. So here you can see diverse shapes of this one species, and even for you guys who don't know much about ostracodology, when you see, for example, this one and this one, you would never say this is the same species, would you know? But people thought, and that was just a routine, this is Henry Covella Deciderma, this as well, this as well. So at the end, the species became so widely distributed and from 200 to more than 5,000 meters. And after the revision, after Brandauer and Tsuhara revised all these data, they came to the conclusion that this species is actually an endemic species to the Southeast Pacific, living at 300, this is around 3,000 meters, and for it, they have had even to erect a new genus, because even its position in the genus was not correct. So what can we conclude so far about cosmopolitanism in ostracods? Only on family level. To a certain extent, we can say yes on the genus level as well. Probably not on the species level. I'm deliberately putting this probably. I don't want to state anything. It is possible. What do we know? We have a handful of samples and a handful of data. So what do we know about ostracods from deep sea? Almost nothing. There are very few molecular studies, but those that we have confirm that there is no cosmopolitanism. However, these very few, I mean 2 molecular studies. Why? Because ostracods, as I told you, living ostracods are they have very low abundance in deep sea. So when you get 2 specimens, are you going to sacrifice them for molecular studies? Probably not. So you're going to concentrate on morphology. And also, when we study in more detail sophropods, they are telling us that cosmopolitanism on species level probably does not exist. So how to study deep sea ostracods? First of all, you need to pay attention when sorting, because ostracods often look like little pebbles, like little rocks. So you're very likely to overlook ostracods. Because when you start working on ostracods, you're probably not going to be able to dissect them immediately. So it's always a good practice to take a photo before dissecting and to use all available information. So you have to, unfortunately, dissect them to properly identify them. If possible, if you have enough animals, keep some for DNA extraction. Then use available keys to identify down to family level. There are some keys, and I am trying to upload them on the website. For further identification, I would suggest consulting the course literature. Unfortunately, literature is quite scattered and abundant, so you have to have good knowledge to be able to deal with it, and if not, ask a specialist, which you are probably going to end up with. So this is a very small letter. These are small letters, but this is not important. You will see the presentation on the website, and these are the major publications which might contain information for taxonomic identification down to the family level, somewhere to the genus level, and if you're lucky, you will be able to identify down to the species level. So thank you very much to all organizers of this workshop and to my friend and colleague Simone, who kindly borrowed me some of her maps. And thank you for listening.
Thank you very much, Ivana. Questions? Slav?
When we work with deep sea samples, we use mostly 2 main views. It's boxcar and multicar. The ostracods, traditionally and according to standardization, belong to Myofauna. And for Myofauna, main instrument is multicore. The multicore tube diameter about 10 centimeters. So square sample, it's about 70 square centimeters. And when we count the ostracods number, we have about from 400 to 1,000 ostracod per square meter. In boxcar samples, we also use the sieve 250 microns. We met a lot of ostracods. When we count number of ostracods from boxcar samples, we have about from is myofauna, and we use the first data from 500 to 1,000 ostracods per square meters. But in multicolor samples, we never met big ostracods, which we found in boxcolor samples, for example, like Batyciteria or Bairdia pilata. And in myofauna samples from tube 70 square centimeters, we never found many species when we found in boxcolor samples. This is like a dilemma. And what we use to count ostracods, how we can count the ostracods?
Well, I have to ask you, do you get these 500 specimens, do you get them whole animals with soft parts inside? Are you sure those are not just sediments, like they're not just shells?
No, we found living ostracods.
Living ostracods?
Yes, yes.
Okay, I've actually never seen
No,
samples with so many.
in myofauna tube, 70 square centimeters, we found not so far ostracods, but when we count on 1 square meter, we need to use the very big coefficient to count the number of ostracods. That's when we have a big number of ostracods.
They are more abundant as meiofauna, I would say, than macrofauna. So I would say multicore would be better,
But we never find in multicolor samples many species of
well, what
ostracods.
can I tell you? You have to pick both. So.
Any other question? Thank you very much, Ivana. So we pass to the next presentation by Paul Valentin Scott on the taxonomy and biogeography of macrofaunal molluscans, with focus on the abyssal benthic Pacific fauna relevant to the Clarion-Clipperton fracture zone.
So are we still awake? I'm flagging a little bit, I don't know about you. And it's actually, I love this stuff. I mean, I've been a benthic ecologist for a long time. And while I work with mollusks, I'm fascinated by all these talks. I'm fascinated by the molecular talks and how exciting those new tools are. So thank you all for presenting this to us. So my approach is going to be slightly different. Everybody's has been different, so that's great. We were given a fairly broad parameter as to what we're going to do. And Yvonne actually gave me a bit of a setup. Number one, she works with bivalve shelled animals, so we have something in common right there. But she also talked about historic cruise or two. And I'm going to talk about that to give context for what we actually know, because as almost all the other presenters have said, except for the isopods, we have a very small data set, or no data set, in the Clarion-Clipperton zone. I want to talk about the recent publications that are available now, and by recent I mean in the last 5 years or so. Best identification tools from my perspective, and a few collecting suggestions that are useful to protecting the samples that you've collected, the mollusks in the samples you've collected, and then finally just a really quick overview on what mollusca taxa we might find. Actually, and specifically, I'm going to talk about bivalves. So my specialty are bivalve mollusks. I can kind of handle the other molluscan groups, but bivalves are my passion. So the Challenger expeditions were from the 1872 to 1876. First real major expedition to focus on the deep sea. They got down to deeper than 8,000 meters. They've recently recalibrated that station, and it might be deeper than 10,000 meters. Over 4,700 new species were described from that expedition. And I want you to think about the magnitude of that, because what you're doing right now could be in that level. You are in a new area that we don't understand well, And you've heard it again and again. Somebody said today 88% of their fauna that they've seen so far, I think is you. We don't know yet. So I encourage you to take care and cherish these samples that you got. The publications that came out of these are still in use today. I use these publications from the Challenger expeditions. There's excellent ones on mollusks. Many of the species in the deep Pacific were described originally, and some of the illustrations actually are quite good. The type material, which us taxonomists go to, is not in such great shape for some of these groups. So we're kind of redefining them in a modern context now. Following the Challenger, the other big one in Pacific deep sea cruises is what I'm focusing on, were done by the steamer Albatross by the United States. Several cruises, I can't remember how many they did, 4 or 5 cruises from 1891 to about 1905, most led by Alexander Agassiz, and that's why we have the Agassiz trawl, Agassiz of Harvard. They also got down to about 7,500 meters, so very, very deep water. And from the molluscan standpoint, it was mostly described by one gentleman who was the curator at the Smithsonian Natural History Museum. And just from the deep Pacific, he described about 218 new species of mollusks. Just in his one publication, 1908, well, he had many decades of publications, and there are many deep sea mollusks. The ones from 1908 are actually nicely cataloged right here, and just all the type species are described. Jumping much further ahead into about the 1950s, the Galathea expeditions. Almost all of this material is accessible on the web for every group. So I think every group we've talked about here today, there's some type of monograph on the deep sea Galathea expeditions that are available on the web. I uploaded the molluscan portions. A very good friend of mine, Jorgen Knudsen, did the bivalve mollusks of this group, and actually one of those manuscripts I've uploaded today. It's one of the best ones found for deep Pacific. So moving on to more recent times. Certainly the French deep sea benthic expeditions, primarily in the South Pacific, starting in the 1970s to the present, to this year, to this month actually. They're down there. All this long series of different cruises that are fairly well documented, again, primarily in the South Pacific, very well published, and many of the molluscan portions of these are included here, including this one that was just a few years ago. So very strong literature, again, not in the Clarion-Clipperton area, but certainly there's going to be some similarities. So some of the monographs that we have available for you as if you're trying to identify these things. At least in terms of the molluscan fauna, we know that there's some influence of Indo-Pacific region in the Clarion-Clipperton area. And so one of the best Western Pacific general molluscan faunas is this one out of Japan by Dr. Okatani and a cast of hundreds, for sure, to put together this wonderful volume that describes both in Japanese and English basically all the mollusks, including the abyssal mollusks. Obviously, the highest number of species in this book are shallow water, but it does go well into the abyss, into 4,000 and 5,000 meters. So a very useful volume to have. I brought a copy, my copy here, so people can take a look at it. It's still available probably on Amazon or something, but I think it's pretty darn expensive now. It's from 2000, so it's not that long ago, but I'm sure it's out of print. So Eastern Pacific, so that's Western Pacific going to the other coastline. Eastern Pacific, Keene in 1971, also did a wonderful treatment of the mollusks, and again focused material was accessible. And she looked at all of Dahl's material that he described. She went to the Natural History Museum in London and looked at all the deep sea material they described, to Copenhagen to look at the Galathea material. So she did a really nice job. And this is especially important for the non-bivalve group. So I'll talk about that in a bit. But pretty much everything is included there. A lot of the original illustrations. So these are the original illustrations that were came out in the original publications. Another one I have to mention, even though this is exclusively shallow water, it's from the Clipperton. So while it's not, it does not directly apply, at least it's in the region, there's potentially going to be some similarities here, and it's actually very, very elegantly illustrated. So if nothing else, you might be able to get things to maybe a family level. There's no descriptions here. It's just a catalog plus plates, but it's a useful piece. I brought a copy of this one as well. In fact, that's a free download through, well, I have it on our website here. And again, I'm focusing again on Knutson's 1970 bivalve work, which is really just magnificent. And it does very specifically target the deep bivalve fauna of the Pacific. So then, trying not to bang my drum, but then we get to stuff that I've worked on recently. So Gene Cohen and Frank Barnard and I started a series of monographs. This first one in 2000, and we took the Eastern Pacific, started with the Arctic Alaska, and went as far down to Baja California. We did cover all the way down to the abyss where specimens were available, and we certainly got down to 5,000 meters or so. We documented about 470 species of bivalves from that region. And then that was followed just a couple years ago in 2012 by a monograph that then went down into the tropics. So this one went from Baja California down to northern Peru. And that was double the diversity, no surprise, being from the tropical region. We definitely went into the abyss where material was available. We certainly got down to 5,000 meters or so, but we did not get out as far as the Clipperton fracture zone. We just didn't have the specimens available to us. We certainly would have included them had they been available. In terms of other groups, I'll go through this very quickly.